multiple access techniques, smart grid communication techniques. She has published papers in several areas, including NOMA for 5G, power line communication, digital modulation techniques. She will share her thoughts on digitization of power networks for sustainable and reliable distribution. Ma'am, please.
Bismillahirrahmanirrahim. Assalamu alaikum, everyone. Rabbi Shali Sadri, Vasali Amri, Wahlul Uqdatam Lisani, Yafqahu Qawli, Rabbi Zidni Ilma. I would like to thank the organizers of this international seminar, ComSat Secretariat, Concession of Islamabad, and we have been a part of this organization team as well, from Energy Research Center, Concession University Lahore campus, and UNESCO, who have been the funders of this event. Related to the topics which have been discussed so far, and since my talk is the last one, we will have an overview of all the talks in the start of the panel discussion just after my talk. However, just to touch upon all the topics, there have been numerous areas which we have touched upon since yesterday, and all of them are significant with respect to energy right now. Energy is the most critical aspect of any country's economy. So, and not only for Pakistan, for the global economy. So my topic today is about digitization of power networks for their sustainable and reliable distribution. Before I go on, I would just like to show you a brief overview of the contents. Most of the slides are related to overview of technologies which are part of the digitization of the grid right now, and which are also futuristic, which could be futuristic innovative solutions in the for the digitization of the grid. We will talk about why digitization is necessary, what can be done regarding digitization, and what are the benefits of digitization. So this is our Lahore campus, a brief pictorial view, the lush green grounds you can see, and our beautiful Mughal architecture. Those who have visited have knowledge about it. I'll just briefly go through my center. So we are the official consultants of this seminar. And these are the, I'm not going to, these are the core areas which we pursue in our center, including smart grids, microgrids, computational mechanics, biofuel, biotechnology, energy audits, and renewable energy. And we have 3 focal areas regarding our center, which is research and development, awareness and trainings, and collaboration, not only industrial, but government and non-government as well. So we try to touch upon these focal areas through research funding, through capacity building trainings, through short courses, through energy efficiency audits, and helping industry with product development. So now to the topic, which is digitization of power network for sustainable and reliable distribution. So why digitize the power network? The question arises, why digitize it? Why can't we go on? There have been several talks today as well on digitization, on supercomputing, on smart metering, on digital twin. Now, thing is that as the processes and the markets grow more complex, the decision making becomes more and more complex with time. And the bodies or the decision makers, they cannot make those critical decisions based on incomplete or information that is delayed information. So that is why we require to have digitization, so that we can address the challenges which are posed to the growing power network in terms of its complexity, stability, and its exponential growth. So we need to digitize the power network, and digitization will help because the digitization technologies are all around us today. Every one of us uses a smartphone. We are always connected everywhere. Wherever we go, our mobile data is on with us. We are connected everywhere. And because my area, you can say inherited area is communication, because We always talk about 5G and 6G technologies, and we say that in terms of 5G, fifth generation and sixth generation communication technologies, we will be talking about very high data rates with very low latency and connectivity providing to the consumers, not only just one device of the consumer, multiple devices. So that is why the connectivity and the digitization is already there. And talking about digital energy systems, we need to identify the needs and deliver it at the right time, where it is needed, and at the right place and at the lowest cost. So this is the objectivity that, or the object we need to address: delivering the energy at the right time, where it is needed, and when it is needed, and at the lowest cost. So for that, we need data, and we have talked about data today. And digitization, not just one part of the grid, but the whole grid, and then end-to-end digitization of the data. So it is already improving the safety, productivity, accessibility, and sustainability of energy systems. And new business models are emerging. We've talked about business models. We are no longer going to remain on the business model that there is one company selling the electricity and we are all buying it from one fixed price. So the market deregulation is on the cards. It's going to happen very soon. And these new business models, they need digitization, and the data generated by that digitization will help make decisions and correct decisions. So the digitization is not a very new concept in the energy sector. Power utilities did adopt it since 1970s, and they tried to incorporate those technologies in the grid. Oil and gas companies were using it to make decision making for exploration and asset management. Industrial sector already had employed process control and automation, and then there's intelligent transport systems. So the global investment in digital electricity infrastructure and software has grown by over 20% annually since 2014. So this is nothing new, but what we're talking about today is the need to involve all stakeholders in it and involve the digitization process in an integrated manner. So let's have a look at the global energy sector and Pakistan's energy sector right now. So this is our global energy problem. Dr. Irfan talked about, I think, energy trilemma. We have a very, you can say, not a very good rating on energy trilemma. It's a global ranking of countries regarding energy. So the problem is that we have exponential population growth, and in economic countries and OECD countries like us, there is a host of economic activity going on, and as we have the greater economic activity, there is the need for greater energy consumption, and then again dependence upon fossil fuel. And if we are not increasing the renewable energy in the energy mix, what happens is that we end up with greater GHG, greenhouse gas emissions, and then therefore the climate change. So the answer is that we need energy which should be abundant, which should be affordable, and which should be clean. So that this is the characteristic which we are looking at in an energy system, and which should be an ideal system. So where is Pakistan standing right now? We are the most energy intensive countries in this part of the world due to inefficient utilization of energy. We are 15% more energy intensive than India, 25% more intensive than Philippines. We generate 28% costlier residential, we are cost in terms of residential consumption as compared to other regional countries. And we generate 26% higher at a cost higher than our neighboring countries, as I've shown you over here. So the high energy consumption basically is one of the reasons is that the appliances that we utilize, they are not very energy efficient. Yesterday, Minister Saab was hinting about the fact that these fans, so I already mentioned it over there, that metal blade fans, they consume more electricity, 40% than plastic ones. So there are hosts of devices that we use every day, but they are not efficient in terms of energy. So this is our current scenario. On the left side, you'll see the generation installed capacity. We have increased 3.6% since April 2021, in April 2021 since 2020. And on the right side, we have seen a lot of statistics, and the same statistics over here, that we are actually relying more upon thermal generation and just 3 to 5% on renewable energy. So this is our current energy mix. So Pakistan's problem again is related to accessibility. 25% of our population still without electricity or with marginal or partial access to electricity. Affordability is another problem as the per unit cost keeps on increasing day in, day out. Reliability, there are power quality issues. There are lesser issues as compared to outages, planned or unplanned ones, but they are still there. Then we have cascading outages. We have witnessed blackouts just a year or two ago, where the whole national grid shut down and the whole life became standstill. Then we need to reduce our transmission and distribution losses, and then we need to incorporate again. The statistics say that Pakistan falls in the topmost nine countries, which is most vulnerable to climate change. However, our contribution is less than 1% in carbon emissions. Then utilization of distributed energy resources is going to be very, very critical when we talk about Pakistan, in remote areas, especially rural communities, where with the extension, the transmission and distribution lines is not very efficient. We had this UN climate change conference, COP26 last year. And there were very strict, or we can say very high or ambitious targets set by the conference stakeholders. And they said that clean electrification of transportation, heating and buildings industry would eradicate fully 73.2% of global emissions. And this was reported by EIA. So the stakeholders in that conference, they promised, or they made a pledge to reduce the carbon emissions. And we are also signatories of the Paris Agreement. So we can keep on either follow the same pattern that we have been following for the last many years, or keep on or go towards another innovative solutions and increase the renewable energy mix in our renewable part in our energy mix. So the new and efficient power systems, they can be driven by three words: decarbonization, decentralization, and digitization. So decarbonization, lesser fossil fuel utilization, more dependence upon fossil fuels. Decentralization, no longer large power plants to supply the transmission grid and then the whole nation to derive their power from the same grid. Instead, we can have distributed energy resources, have microgrids or mini grids, generate at the same locality, utilize the local resources, and then provide the power to that locality. Then digitization is the last part where it's going to play. So I'm going to elaborate that now. So digitization to the rescue means we have better facilities to connect and operate generators of all sizes and technologies. We allow consumers to play a part in optimizing the operation of the system. The consumers now, as most of us have rooftop solars, or most of the people are going towards rooftop solars. And if they are prosumers right now instead of consumers, and with net metering, they're also selling their electricity back to the grid. So they're playing a part in it. Now the regulators or the government agencies can also give incentives to the prosumers to cut down their consumption during peak hours, and then play a part in peak shaving of the demand that is put up for the whole nation. Now, these prosumers can be provided with greater information and options for how they use the supply by the utility. So we are no longer talking about one-way flow of communication or one-way flow of energy, which was the conventional grid. This is the new grid that we are talking about. This is one way. There's two-way communication between the utility and the consumer. There's two-way flow of power between the utility and the consumer. So we can also then, thus utilizing those renewable sources, we can reduce the environmental impact of the whole electricity system, and maintain and even improve the existing levels of system reliability, quality, and security of supply, and improve the existing service efficiently. I'll elaborate these points just a minute. So my topic topic of the talk was related to reliability and security. So reliability, we can improve the reliability through decreased outage duration and frequency. Since I come from Lahore, and there's a large industry in Lahore just around the campus that we live in. Actually, I live in there as well, in Rawalpindi. So that there are industrial states, and if their power shutdown occurs just for a few minutes, it costs them huge amounts. their whole process of production stops. So none of those industries can afford these power outages, either planned or unplanned. That's why they have their backups right now. So we have to improve the reliability and these outages and their frequency of outages. It also affects our social life as well for a normal consumer like me and you. Then reduce labor costs such as manual meter reading and field maintenance, automatic meter reading, automatic metering infrastructure. Once placed, can help us a lot. When I come to that slide, I'll just try to elaborate, but right now I can say this, that automatic meter reading will help the utility get the reading not at the end of the month. They can be collected like Dr. Shahid Kamal Shaizover just said that we have either 15 minutes or even by minute or 2 minutes data being collected from the consumer in a digital twin or in a grid which is digitized with smart meters. Unfortunately, we have not been able to fully implement these smart meters in our DISCOs. Partially, they are available in either in ISCO, some in PESCO, some in MEPCO, and they have very good results due to this smart metering. But the will has to be there to implement these smart meters, because they then eventually will lead to transparency, not only in billing, but also helping the utility find out about load forecasting, actual load forecasting and correct values, then also find out about what's going to be the peak load in some areas, find load profile trends, and so on. So there's a host of opportunities with smart metering data over there. Then we can also reduce non-labor costs, such as those use of field service vehicles, insurance damages, so that the utility does not have to implement manually these methods. Then reducing transmission distribution system delivery losses through improved system planning and asset management. We had certain meetings, being in Lahore and being in Energy Research Center. We try and you can say talk with various stakeholders, and while we were talking with NTDC, we all know that they place their forecasting based mainly on GDP growth. So but they were of the view that new parameters are coming in which need to be incorporated so that correct modeling or better modeling can be done of these systems. So these, again, digitization can help in here, and those parameters, once incorporated, will help in better and accurate load forecasting. And look at what we are doing right now is we have generated capacity for the peak load and not for the base load. And that's what's causing the problem. Our industry is not up to the mark, and that's not utilizing that energy, which was actually generated for the peak load. And then we come to security. So energy security, protecting revenues with improved billing accuracy, prevention and detection of theft and fraud. My student, he just is about to pass out with a PhD degree from Lancaster University, and he has worked on modeling of load forecasting and theft detection based on machine learning concepts. So this is one thing which, if we have the data, if we apply the real actual algorithms over there, we can detect the anomalies, have proper trends over there identified, and if there's an anomaly in those trends, then we can have at least an indication that something fraudulent is occurring over there. Providing new sources of revenue with consumer programs such as energy management. So this demand side management is there, and allowing the consumer to respond according to the incentive provided to him or her is again through this energy management techniques. Then we can defer capital expenditure. A country like us, a developing country, we cannot afford to have large power plants installed every 4 or 5 years. We already have certain capacity in the system, certain generation is there. Why not utilize that efficiently? So we can defer that capital investment and utilize it somewhere else instead of keep on building those capacities. So we can fulfill our national security objectives. Improve wholesale market efficiency. So we are also talking about deregulation of the market, and that can be helped again with correct data being available. So the digitization of the power sector can also reduce costs. So digital data analytics can reduce power system costs in at least 4 different ways. By reducing operation and maintenance costs, we are talking about predictive maintenance. I just told you that if an industry or even a grid or distribution grid or substation, they have good data available with them, and anomalies are identified. Maybe predictive maintenance can be done instead of going for a failure. Improving power plants and network efficiency, reducing unplanned outages and downtime, and extending the operational lifetime of assets. So that again related to predictive maintenance. So according to EIA, we have about 80 billion US dollars per year can be saved from 2016 to 40 if we are using digitally enabled measures in the grid. So I've just talked about this, so I'm going to skip the slide. So our key drivers over here are for the modernization of the grid: reliability, resilience, efficiency, sustainability, operational effectiveness, and consumer engagement. We will touch upon these topics in detail. So the pyramid goes like that: starts with digitization from the bottom, goes to digitalization, and then enterprise integration. So digitization, simply digitization of data, converting into digital format. And then digitalization is end-to-end sharing of digitized data, so that the businesses can utilize that data and across the entire enterprise, improving operations and effectiveness of consumer delivery. And then in enterprise integration was optimization of this data for strategic data-driven decision-making, and digital processes are applied to solve business challenges. So again, having, you can say, correct data or correct values to base our decision upon, correct trends, and not just making a decision on our whims. Instead, we have some solid grounds to make those decisions that can again be through digitization. So these are some of the benefits, some of the savings. You can see smart homes can save us a lot of, this is about efficiency. I'll show you a slide on efficiency right now. Yes, digitalization and efficiency, you can see we have system energy efficiency, we have demand side and use efficiency, and we have demand side flexibility. So these efficiencies again are based on digitalization, and we have energy system cost saving, variable reserve, renewable integration, energy consumer empowerment, and end user efficiency improvement. So cycle goes on, as you can see on the right side over there, and we can implement these, you can say, energy efficiency measures based upon the data that we have or we derive from the digitalization process. Regarding efficiency, I would just like to add over here that efficiency energy efficiency is one part which can help us a lot in saving, because we talk about energy efficiency when we say we need to have efficient appliances, replacing our bulbs like with LEDs, have efficient fans with efficient windings, and then a lot of electricity we spend in cooling our homes, air conditioning in summers. If we build our homes or retrofit our homes according to our climate, we can also reduce, so again, that goes towards green building. So data is the lifeline or lifeblood of any utility. All the data the utility holds needs to be identified so it can be easily accessed. Now, thing is that Dr. Kamal was saying that the data is generated in one format, then another. So it has to be unified, integrated, and made available in a unified format for all to be utilized, for all to have access. Dr. Masroor Saab was saying that it needs to be accessed by everyone, publicly available. Data architectures need to be implemented that take into account multiple data formats, locations, velocities, and increasing volume of data, including real-time data. The utility needs secure and controlled access. Utility needs to have a whole holistic view, a 360-degree view, so that every part of the grid, every stakeholders, load profiles, data consumption, projected consumption, it is all with them on their computer screens. So then they can make predictions and forecasting. Data platforms that are adopted must allow for seamless two-way exchange of data with trusted partners. So we need to have a complete system in place so that once acquired, it is safe, secure. It has to be with the trusted partners, and it can be then seamlessly exchanged with the required stakeholders. So these are the technologies: Internet of Things, big data analytics, machine learning, artificial intelligence, demand side management, and demand side response. These are the technologies which are at the heart of digitalization right now, and that can be utilized in the grid. I will just, how much time do I have? 20 minutes. Okay, I'll just go through these technologies. So Internet of Things, and then it combines into, we are all using internet day in, day out. What is it? It's a connection of various servers connected together all across the world. So when we send an email from here, it goes from node to node through the network, and it reaches its destination. Something like this, information in the energy internet can also be communicated. So the cloud-based systems, they allow utilities to monitor, control, and optimize the rapidly growing number of solar power systems, battery-based energy storage systems, smart thermostat, thousands of other new internet-connected devices that generate, store, and use electricity. So these smart devices that we say have the ability to communicate, smart meters have the ability to communicate, even control, can control through the utility, monitoring by the utility. These things, they can be cloud-based, the data can be there, and it can be then allowed to be shared with the concerned stakeholder. DERs, they can be distribution energy resources to use to improve the grid reliability, reduce energy costs for the consumers, and most importantly, increase the use of renewable energy resources. So distributed energy resources can be utilized in this Internet of Energy. So one day, I think we will be talking about such a energy network in Pakistan that one side we plug in our power, and it can be accessed from the other side. And if it's not just national grid, it could be other options as well. Then we have IoT. IoT is the, you can say, the Internet of Things, fourth industrial revolution. Sensors. When we talk about monitoring and control, first we need to sense. And these IoT devices can be simple communication, intelligent electronic devices, either placed on the substations, over the transmission lines, or through the distribution network, so that we can monitor the health of the distribution and transmission lines. We can have our smart meters and IoT device. So all these devices, these IoT devices, they are the sources in the network which help us in asset management, and our asset where is the grid. So the platform will collect the data generated by these assets, which are the devices in the grid, and from external or open sources such as weather, building, heating, set points, and car usage. Then we can apply algorithms on these the data, and then that algorithms, they come into play, providing essential decision making by using accurate predictions of production, consumption, and grid energy tariff. So these are some of the optimization areas which can be beneficial using IoT. For example, we can have self-sufficiency by controlling and increasing self-consumption, take advantage of flexible energy tariffs, optimize the electric vehicle fleet management and vehicle to grid and grid to vehicle exchange of energy can take place. Improve load balancing and peak shaving, and optimize the balancing of the national grid. So these, again, the areas of energy can be optimized using IoT devices. So AMI, we have just talked about AMI, so I don't think I need to go over it again. So data analytics, these are the various types of data analytics, starting from descriptive, diagnostic, predictive, and prescriptive. And these analytics types, they can be applied at various stages in the grid. The descriptive models describe consumer behavior for demand response programs. These from these, the data that we acquire, we can diagnose, we can do diagnostics on the data, and we can understand the behavior of the consumer while we are looking at the data, analyze their power related decisions. For example, we all know that near Eid or in Ramadan, when the Ramadan is about to end, the commercial areas are going to have rush, and the power utilization or consumption is going to go up there. So these, when we have data regarding such events, such social events even, so that we can have diagnostic models made from that data. And then data analytics. Create models that predict future consumer decisions and hence power need. And then finally, prescriptive models. They can provide high-level analytics to influence smart grid marketing, engagement strategies, and decision-making. So these are the various types of analytics that we can apply into the grid for data analytics. So this is basically, again, digital data analytics. We can reduce the operation and maintenance costs, allow greater efficiency through improved planning, efficiency of combustion in power plants, lower loss rates in networks, and better project design throughout the overall power systems. Then we can have electricity networks where efficiency can be achieved by lowering the rate of losses in delivery of power to the consumers, flows and bottlenecks to be better managed by grid operators. So we can have such bottlenecks where there's congestion or there's more, you can say, consumption at one point in the grid. We can also have more efficient solutions to this once we have the data and we can analyze it, predict it, and forecast something like that can happen. Reduce the frequency of unplanned outages and then reduce the overall cost, really increase the resilience and reliability of the supply. So again, network failures are very expensive. Our outages, even brownouts or blackouts, they are heavy on the economy, and we need to avoid those. So you can see we have various data, you can say various techniques, like at the heart is the data analytics, statistics, machine learning, and artificial intelligence. So I'll go over one by one. Machine learning algorithms, as we know that these are algorithms which learn from the actual data and they keep on updating themselves based upon the data which is fed into them. So machine learning algorithms are practically used for clustering data gathered from the distribution grid. Dr. Kamal was saying this morning that there's a huge data generated from the residential side, even if we have from the smart meters. Is that data meaningful? Is that data useful? We need to have meaningful data extracted from that. And for that, we need to filter it, cluster it, classify it. And this is one application which can help us do that. So again, one example is that we can cluster data from low voltage feeders with similar load patterns for DSOs or distribution side operators. Then machine learning can use smart grid data to understand the underlying structure, gain useful insights, detect anomalies, generate hypotheses, and then predictions can play a significant role in powers. And then again, once we have learned about the situation, we can predict, we can better forecast. So as you can see in this figure, we have the residential sector, the commercial sector, the residential sector, and the industrial sector, and it is spread by renewable and non-renewable thermal generation, wind power, solar, and then there are the machine learning and data mining techniques are applied to it, and then we are actually analyzing the data, creating dynamic adjustment of the power generation systems, using analysis for management, and then we are also utilizing it for better production and smart and efficiency consumption. So we've talked about predictive maintenance. Utility use cases are based on AI, artificial intelligence, including predictive maintenance. We have this very common, those who have come across some discos, actually what happens is that some vegetation outgrows and the trees are outgrowing and there's disruption of electricity due to some stormy weather due to this outgrowth vegetation. So this even can be predicted and AI can be utilized to do this. Then voltage ampere reactive optimization can be done. Estimating times to restoration of service once a fault occurs. Dr. was saying that we, even in Lahore right now, whenever there's a stormy weather, what happens to us, there's a complete shutdown of electricity, and the next few hours, or at least 20 to 24 hours, the LESCO people, they go pole to pole trying to find out actually where the fault occurred. So if we have IoT devices, we have data from those devices, we can have AI algorithms, at least we can pinpoint or at least isolate that fault. We are talking about in smart grids self-healing, isolation in the first place, then self-healing, isolation, so that none of the other community members who are not actually directly related with that fault are affected. So this can be done, and this can be, again, there's need to be a will, and when there's a way. So again, other digital technologies include augmented reality, digital twins we've talked about today. And these are all the technologies which play a very important role in grid modernization. So I'm going to skip a few slides because I have replicated them. Here, demand side management, you can see. So demand side management, as we've talked about, we have referred to any activity adopted by the utility so that they can manage the demand. So they don't need to insert very big power plants. If there is a very peak demand, they can have appropriate energy management systems employed. And then this demand response, allow the consumer to voluntarily reduce their loads and give them credits for that, so that they have this incentive based you can say policy should be made, so that they have this incentive to voluntarily reduce their load. And for that they need to be informed, and for that they need two-way communication, and the utility and the consumer need to be on the same page for this part. So load forecasting, we've just discussed. There are uncertainties. There is load price forecasting. There's a load of big data for short-term and medium-term forecasting. And not one parameters, but there are a host of parameters, not just technical ones, but non-technical as well, that play a role in making the next days, next months, or next year's consumption. So the load profiles can be collected, the trends can be seen, or anomalies can be identified. And then the next, you can say, looking at the country's production, projected increase in industrialization, we can have this load forecasting. Demand response, we've just discussed. So in the end, we are also going to look at this in the panel discussion. We can also have digitization technique for clean energy technologies. We can have carbon capture and storage techniques, and we can have digital technologies application for carbon dioxide capture, which are similar in nature and benefit to digitization industry and power generation. And optimization of control processes through automation, enhanced data collection analytics are likely to reduce overall cost. It's a very small thing. One of our faculty members, he has an industry as well, and he was looking for a solution in his industry. And what he did was he installed small IoT devices in his industry, and he found out that there was a huge amount of, rather more, a greater amount of total harmonic distortion. Because of that, his devices were burning out. He used to deploy new devices, and then they used to burn out. So through IoT, through digitization, he was able to pinpoint the solution, and then he had an efficient solution in that manner. So this is very small thing, but it can be employed by even small industries. So these are some of the IA recommendations which can be employed for digitization. We need to build digital expertise within our staff. That means we need to do capacity building. We have a huge resource in our universities. Academia is also a very big resource in this. We can build this digital expertise. So this can be helpful in digitization. Ensure appropriate access to timely, robust, and verifiable data. Again, data there. Build flexibility into policies to accommodate new technologies and development. Fortunately, government has come up with new policies in recent past regarding EVs, regarding microgrid, regarding energy efficiency, very recent policies. But they also need to incorporate policies regarding digitization so that we have standard digitization for each stakeholder in the grid. Experiment, including through learning by doing pilot projects. This is very important, because when we are doing something new, we do not know what's going to come as an outcome. So we can do pilot projects, and those pilot projects not necessarily can be very big, but they can be proof of concepts, and they can be carried out by again by academia, by students, and they can be very helpful in indicating solutions. Then focus on broader overall system benefits, monitor the energy impact of digitization on overall energy demand, incorporate digital resilience for design into research, development, product manufacturing. So these are some of the IEA recommendations. In conclusion, I would like to say that there's a critical need to address energy innovation solutions customized to a country's needs. And the policies are needed to make sure that consumers, appliances, and equipment participate in demand response and smart energy systems. Fortunately, we have come up with microgrid policy. We also need to have some policies on demand side management and demand response, offer incentive to our consumer so that they are also aware what's happening with their bills. They're also aware that how they can cut down on their bills, how they can participate. If they're doing net metering, how is it benefit to them? If they're not even doing net metering, then can they reduce their consumption during peak hours? We just have two rates, one peak and one off peak. Whereas once the market is, you can say, deregulated, it can be more flexible. It can change, let's say, hourly, or with the cost, it can change. So we need to do that in coming future, inshallah. R&D activities to focus on energy innovation solutions such as energy digitization, energy efficiency and conservation, incorporation of new technologies, micro. These solutions don't need to be very hi-fi solutions. As I just talked about, we can start with very small devices, very small areas, and then we can grow into bigger ones. One side, the government side is to make regulation, to make policies. On one side, we need to start somewhere. We don't need to keep on waiting कि जी चलें कोई दिन आएगा बहुत अच्छा, जिस दिन बहुत अच्छा कोई incentive मिलेगा, government एक दिन हम सुबह उठेंगे और government ने सब अच्छा कर दिया होगा. This is not going to happen. So what's going to happen is we need to play our own part. We being researchers, academicians, we are also responsible. Government in their policy making responsible. So why not start with a very small part? Why go for a very hi-fi thing? Start with a small part, and we can do some research, make an efficient device, help the government with it. And government has been very good in doing bringing out codes, standardization of devices, 3-star label fans, and so on. So there is a host of measures they are taking, but we need to pitch in as well, and we are always open. जी 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 Sure. That yes. We will need to collect some data as well over there. Yeah, but we'll surely help you out there. Yeah, thank you. We'll do that. Capacity building and R&D. So this is something we do on a very small scale in our energy research center. We do capacity building. You see, it's not an example to quote over here, but I would just like to mention over me being a communication person. Dr. Shajil knows I'm a signal processing and communication person. And when I was handed over the energy research center, I thought, what should I do with it? I'm not a person, I'm not a power person. But then I tried to find out my niche over there. I literally did a course with Nika, that training of trainer course. And you believe me, at my stage in my profession, when it's very hard to memorize formulas. So I did that. So thing is that we need to do capacity building, and that's what we're doing. Once we've got the training, we are energy experts in Edge as well. What we are trying to do is impart it to our students. We try it and play our part. So that is something each one of us should contribute to. Distribution companies need to transform to digital utilities to continue to survive and thrive in the future. So again, unfortunately, today it was discussed that DISCO's role is going to be changed. Today, their role is just distributing and collecting. That should not be it. They should be full-fledged power suppliers, and they should be responsible for what they supply in terms of cost and buying and selling it. Then we need to decarbonize cities infrastructure. It is doable with technologies and a new way of thinking. I have a collaboration with the assistant professor. He's doing very good work in Malaysia on hydrogen. And hydrogen, as you know, we all know that it's the fuel of the future. Only its safety and stability is the issue. So things like this, innovative solutions are there. Only question is how to start, where to start. So I'm just asking my students and my faculty members over, so don't wait for an opportunity to come by. So start with a very small thing and it can grow up. Thank you so much.
Okay. Thank you so much, ma'am. Now we move on to the most interesting part of this seminar, the panel discussion, basically. The topic of today's panel discussion is transition towards clean and green energy. So firstly, I would like to invite our group of panelists. I start off with Mr. Ali Nawaz Sahab, Director General Projects, PPIB, Ministry of Energy, Power Division. Sir, please. Next, Dr. Irfan Yusuf, Advisor, Technical, NEPRA. Next, Mr. Owen Muhammad Arshad. He is a proud alumnus of our very own department. He is currently serving as country manager, Pakistan Elam Energy, which is an international organization having one of the office in Pakistan. Next, we have our chairman, Professor Dr. Laik Khan. Sir, please. Next, we have Engineer Asad Mahmood Saab, Manager Technical, National Energy Efficiency and Conservation Authority, NECA. Sir. So we have our moderator for this panel discussion, Dr. Sobia Beg, Head Energy Research Center, CUI, Lahore campus. Ma'am, please.
Thank you. Again, Assalamu alaikum, everyone. So I welcome you all to this last activity of this international seminar. Its theme is transition towards clean and green energy. As I've just discussed in my talk, we need to incorporate renewable resources, increase its proportion in the energy mix, so that we can meet the SDG 7, the Sustainable Development Goal, the 7th goal of UN, defined by UN, for provision of affordable, reliable, sustainable and modern energy for all by 2030. Unfortunately, as I talked a few minutes ago, we are 25% of our population is without electricity, and we are still very much dependent upon fossil fuels. And we have a lot of issues which every organization in Pakistan deal with, starting from theft to unreliable supply to you can say losses in the transmission and distribution lines. Then there comes failures. We see blackouts. We have limited fiscal space. We are a developing country, and our circular debt is on the rise. It's in trillions right now. So we need solutions, and we need solutions, quick solutions, and those solutions that can contribute towards clean and green energy, because this is the right time for us to think on it. Although we are not the contributor towards carbon emissions, but still we are the most affected ones. So why not have a thought on it right now, and have a thought that we should not be one of those countries which are left behind in this race. So we need to contribute towards it. So I would like to thank my panelists for joining us today in this panel discussion. And I would like to start the debate starting from Dr. Irfan Yusuf. And I would like to ask Dr. Irfan that can you please elaborate on immediate and short-term and medium-term measures, regulatory measures that may help us in this transition towards clean and green energy. Although the question is quite vague, but I trust that you can help us, our audience, understand the problem and what the regulator can do in this regards. Thank you.
Yeah, it's a very good question. Thank you, Dr. Sobia. Just to highlight that we are entering into an arena where we already are pushing towards increasing share of renewable power. Regulated from the regulatory context, we already have set a base for enhancing share of renewable power in shape of having a very conducive renewable energy policy. The government is opening up the market wherein we are providing a full flexibility for renewable power to integrate. The grid code and the market code are designed in a way, they are coming up now, which will channel increasing the share of renewable power into the energy mix. Um, Besides this, there are certain measures which being regulator and EPRA is taking up that will help increasing share of renewable power. Includes uh, we already have announced net metering regulations based on renewable power. We are going to build those upon so that the consumers can get benefit of this resource. We're also going to launch the regulations for microgrids so that the end consumers can get in the remote areas, particularly they can get benefit of those resources, um, with the view to increase the share of renewable power. In addition, we are looking at how the electric vehicles can become very conducive load and can get benefit of renewable power to feed in. And this is another area where we are bringing in we already have made the changes in the CSM, the consumer service manual. We are also going to bring on the regulations. Towards the digitalization platform is a roadmap which we have already undertaken. We are coming up with a very conducive regulations for information technology and operational technology management, keeping in view the cybersecurity and latest innovations, technological innovations that Dr. Sobi has indicated, so that we can build upon the infrastructure, upon the digitalized infrastructure. From there are certain other parameters which the government is now looking at, particularly to capitalize the dependency upon the indigenous resources, with the view to ensure the energy security and reduce the electricity cost. To that manner, the IGCP is already on grounds, and now we are looking towards competitive procurements. The new procurement regulations that the NEPRA is going to bring on, there's a call for competition and generation of least cost electricity. At this stage, renewable power are the one who complies with the criteria for least cost generation, and they're going to be the most suitable option in coming days. With these measures, we believe we can enhance the share of renewable power. However, in doing so, being regulator, we are very cognizant of the fact that wind and solar power are the intermittent resources. In order to maintain the security and reliability of the system, we need to bring upon the flexibility in the transmission and distribution network. For that purpose, we are working with the transmission and distribution companies to build upon their systems, and we are allowing them the required investment so they can ensure management of higher share of renewable power. So these are the initiatives which we already have undertaken, and they're going to make a shape of energy mix, which I showed in my presentation, that the Pakistan is going to see more than 60% share of clean renewable power by 2030. Thank you.
Thank you, Dr. Saab. Just something for my interest, I would like to ask you this. What's your take on asking the DISCOs to deploy smart meters in their distribution?
Yeah, actually, there are two stages where the distribution companies are now working upon. At the PMT level, they are very actively pursuing to install the EMRs. But the AMRs are not the solution. We have to have AMI for that purpose, and we have given them full investment source for that purpose. So at PMT level, they will be doing in next 3 to 5 years, and the next regime, they will go to each consumer level. The meters will be converted to AMRs.
So we have Mr. Awan Arshad over here, who's country manager, Pakistan Elam Energy. Arshad, since your company is a multinational company, deals with automation equipment, how do you perceive the role of microgrids and mini grids, which are off-grid and on-grid, in the transition towards green and clean energy in terms of your product development that I'm asking? We have a very generalized discussion today and yesterday as well, but in terms of your products, could you please elaborate?
So, Assalamu alaikum. Thank you very much for inviting me. In terms of if we specifically talk about microgrids, then I think that specifically if we talk about Pakistan and transition towards microgrid, then it will take like maybe 3 to 5 years going towards the microgrids. But the product development, as we are like European company, so if we talk about the product development in the European American region, then the basic concept is that those guys are shifting to microgrids. They are minimizing the transmission, and they are more inclined toward the energy sources which are available near to the specific area. They are utilizing like wind, solar, hydro, tidal. Even now the batteries are playing huge role in the microgrid segment. Then they are pairing the microgrid with solar, batteries, wind, generators, diesel generator. So the R&D on the products is like going like anything. All the products are available in terms of microgrids, but the thing is, if we specifically talk about Pakistan, then it will be taking a bit time shifting toward microgrid, and we are not a very financially stable economy.
Yes.
Shifting towards that thing.
Mhm.
So it will be taking a bit time.
So what do you think, do you have, there's always room for R&D activities on standardization of these devices, if there can be applied worldwide or globally, if you take it from one part of the world and take it to another part of the world, are you doing R&D towards that end?
Basically, standardization depends upon the area. The European standardization is different.
Mhm.
Australian standardization is different. African is different. American is different, and we are more under the standardization and the codes, because the main products come from the Chinese market.
Mhm.
So I don't think that standardization of product for the whole world is a very feasible thing, because
Okay.
every country have different regulations and different grid codes
Mhm.
and different requirement, different energy generation sources plus different energy mix.
Right.
So
Okay, thank you. Mr. Ali Nawaz, on one side, we have this global debate of switching to clean and green energy. The theme is this, as you very well know. But as you're a vocal person in this respect, I would like to ask you that coal is one of the most abundant resources, rather the most carbon intensive one as well. So how would you like to comment on integration of coal technologies, clean coal technologies in this scenario, not just the regular conventional technologies, but the clean coal technologies? Thank you, sir.
Thank you, madam, for inviting me in this discussion. Actually, for the first time in Pakistan, we have introduced supercritical technology, rather ultra supercritical technology in coal-based power generation. Although in China and India, they have not introduced fully 100% this ultra supercritical technology till now. Almost 2 or 3% or even 4% this technology is installed in China. In India, our neighboring country, it's less than 1% ultra supercritical technology is involved. What is happening in ultra supercritical technology? They have the gadgets like flue gas desulfurization units. They are the integral part of these units. They reduce up to 0 level sulfur oxides. And again, they produce 0 NOxes. They have installed electrostatic precipitators. They reduce the particulate emissions as well as carbon particles. The only thing which we are lacking is the carbon capturing process. So we are in a way, hopefully we will install in the existing plants. But on the other hand, we have abundant resource at Thar. We have almost 175 billion tons of coal available in Thar. That is equivalent to almost Saudi Arabian and Iran's oil reserves, twice than that. But unfortunately, we have not so far reaped any benefit from that. And by the grace of God, we have installed one plant at Thar. So far, it is generating successfully 660 megawatt while employing this technology. And on the other hand, we have installed another plant that is based on ultra supercritical technology. That is Lucky Electric Power Plant. That is the capacity of 660 megawatt at Port Qasim, Karachi. There was a myth that this coal cannot be transported, but after the installation of Lucky Electric Power Plant at Karachi site, we have successfully transported 300,000 tons coal to that, and we have burned that coal, local coal, in that plant. If we consider for a minute the cost, we compare the cost, we can sell third coal at around $4 per million BTU, whereas imported coal currently being traded at around $26. Sorry, $16. That is $16 per million BTU, whereas RFO and RLNG, that is even more than $26 per million BTU. We are a poor country. Rather than relying on imported fuels, we must immediately switch over to our local coal so that we may produce cheaper electricity for the sustainable development of the country. Once we produce cheaper electricity, we can survive internationally. Otherwise, we will be handicapped because all the dollars we will drain out in the purchasing of fuels. Although I am very much supporter of the renewable energies, but that is intermittent source. That is not a reliable and available all the time. So we need to have a base load. For the base load power plants, we have two sources. One is the nuclear. Again, fuel is imported. The second one is the coal, and the rest of the fuels are imported. So we must rely on local coal. This is the time we think, and we may strategize and frame our energy basket in a way that we may produce cheaper electricity and a sustainable energy in the future development of the country.
Thank you. But I think those carbon capture techniques and storage techniques need to be incorporated with it. Without that, it will be a disaster to do something like that.
Our plants are mine mouth power plants. There is an open pit mine. We just capture that carbon and bury it into the open pit, and we reclaim those pits, open mines. This is the available option we have. We can easily do that. So this is the option, and we immediately go to that. Furthermore, one point I would like to highlight here that these plants are not following our local standards. These plants are designed in IFC and World Bank standards. So although our local environmental protection agencies are continuously monitoring these projects, but basically these are designed on World Bank standards. So that is much more lesser than the local standards. So that's a good point, and we are very much cognizant of our environment, and we will not pollute our environment. Again, FGD has a positive point that it captures most of the carbon during capturing of this sulfur.
Okay.
So this is a very positive point.
So let's hope that we can implement, we can utilize our indigenous resource with carbon capture and storage. We have with us Engineer Asad Mahmood, Manager Technical, National Energy and Efficiency Conservation Authority. Asad Saab and I have had some discussions in the past, and NECA has come out with the National Energy Efficiency Conservation Policy in recently, and they have had a very wide, I think Asad Saab would be better able to elaborate, wide discussions with all stakeholders, starting from one end of the country to the other end, starting from, I think, Gilgit-Baltistan to Quetta, Lahore, Karachi, and you name it, they have been there. So Asad Saab, could you please, for the benefit of our audience who may not be familiar with the policy, could you just highlight a bit of your policy so that we understand and recognize the significance of energy and efficiency and conservation as a nation? Thank you.
Thank you very much. Regarding policy, definitely there are other policies which are already there in the market, like you might be familiar with National Electricity Policy, and out of that, one of the specific section is focusing on the energy. So dovetailing that with the National Energy Efficiency legislation and this policy which is being promulgated, or others we can say being revised at the moment, because many of you might don't know that there was such a policy in 2006 which was called National Energy Conservation Policy, and based upon that most of the CDM projects you can see in their project design documents regarding energy and renewable energy, it has been reflected there, but definitely the follow-ups, or you can say like the framework was not there, which was compelling the end users or any stakeholder to to really look into it and apply. But it was like being referred in most of the literature, in most of the universities' research papers, but how effective it was. Then there came another policy aligning with it, was a Ministry of Climate Change, from Ministry of Climate Change, the climate change policy. And there again, some KPIs were mentioned regarding alternate energy adoption, renewable energy technologies adoption, and similarly the energy efficiency ambit was discussed. So right now, the thing which has changed is now the legislation. One of the legal tool which was missing at that time was the absence of the legislation. So that the legislation is there now, and it's different rules and regulations are being promulgated. So this policy, which is which was open for public consultation, and still like the inputs are being given by different quarters and different stakeholders, that is aiming at like towards saving of energy to the extent of 9 to 10 million or 12 million tons of oil equivalent, and what is the rationale behind it over a period of like next 8 years, where we are going to stand in 2030, and then how often it is going to be revised, and then the targets, sectoral targets, which have to be there and identified. And so these all things are being mentioned somewhere, somehow, and would be notified after due diligence process, after collecting all the comments, because there have been like 438, to be very specific, we have received like about 500, you can say, long inputs by different participants and stakeholders, and analyzing those, which one to not add and which one to add. It's like something which we discussed in length and breadth today, even in the session in which I was supposed to be there, but it was like suddenly called, and that aspect was being discussed. But nevertheless, the policy is will be having the practical aspects, the activities, set of activities which it has to do in short term, medium term, and long term basis. And like policy without any action is not going to be giving any results. And we wish, and from academia, you can critically analyze the policies, the the deliverables. If they are not being met, what could be the hurdles? So you can facilitate the departments to effectively implement the policies, and such forums like this are always helping hand for institutions like us, because it's in the evolving phase, and to set the right course is very much essential. And again, like there is no silver bullet solution, because every city, every region has different priorities and different problems that have to be addressed. So efficiency is one of the common theme which needs to be added to reduce the capex cost and other in improving the life conditions of the people. And as you just said, that we started from like outskirt areas of GB and other AJK. And so there, the set of problems, even in Balochistan, the set of problems are totally different. Like even we're talking about like green technologies and things like that. But first of all, the basic right, access to electricity is something which they need. And they are willing to change, people are willing to adopt. I will close by giving just one quick example. In the Raksha, there are 250 brick kilns. And during this policy consultation, what we came to know that the EPA have given notices to all those kilns to convert it or close it. And it was challenging, or they were for you can say the job aspect, social livelihood impact was very much seen over there. Lot of huge hue and cry. So one of the things which you were discussing, and Dr. Irfan also mentioned, the solution to that problem came out to be like without electricity, reliable, continuous electricity, they were not able to operate even that like proven green technology or technique, the zigzag thing. So so now they are deliberating to have microgrid for those 250 kilns over there, so that they can be centralized control, and the barrier towards transition could be addressed under some policy and legal framework. So these are a few things like I just wanted to pitch. Like every region has different set of problems and have to be addressed in a different way.
Thank you. So, sir, what about a common consumer? If they adopt some energy efficiency measures, what incentives do we have to offer them besides their bill being curtailed? And can we offer them some incentives? Like then we will have a better demand side management, I think.
Regarding apart from only changing of appliances, and again, one of the area where we were also discussing was like the cultural change and giving the nudges to the society to like change their daily day-to-day usage pattern of electricity. So so the fiscal incentives and specifically aiming at the youth is one of the key area, and gender, the role of women has also been highlighted in the policy.
Yes.
You know that thing very well as well. So I think like in terms of fiscal facilitation, the minister was the Minister for Science and Technology, and he's very much focusing on giving this kind of incentive which you are talking, that if there is an efficient technology and if financing is the barrier, then remove it. And how it could be done, go for massive procurement or adopt the model of like SNGPL, like installments, installed solar geysers. So similar scheme for fans, fan replacement scheme is also being considered. On pilot scale, it's in practice now. 2 or 3 different manufacturers on their own have started that scheme, replacing inefficient fans with Energy Star rated fans on their own, not mandatory, but we are analyzing their results, and hopefully soon we can interact through NEPRA with the discos and other stakeholders, how that financing model could be developed. And I think like Dr. Irfan has been a part of this journey and transition throughout in this labeling regime, and I appreciate his support always from in personal capacity and going out of the way to make the things happen. So I think like that it's on the table based upon the existing practices which are there. Solar geyser is there, but again, there are 1,000 solar geysers which have been procured, but again, like hardly like most of them found the customers at the end of the day. The financial tool is there, but the demand is not there. That's also another thing where media sensitization, although they have the awareness message at the back of the bill, but still people are reluctant. And then it evolves the hurdles into it. What are the hurdles? Even in Islamabad, I was facilitating 5 or 10 of friends of mine or relatives. They were not able to find a reliable plumber. There was only one, and he was over-occupied, and the time when the people have the time, the plumber is not available. So that's again, so our universities can, so another aspect by virtue of being over here, I would like to request academia and ours, we are also interacting with TEFTA, that these small skills like electrician courses, rewinding courses, motor rewinding courses, and even be it fan motor or induction motor. So these courses have to be like looked into. We need to make practitioners, even though we are engineers, but we have to be a practitioner. So such practical things have to be added somewhere in our curriculum, which were missing. And we can also help not only the electricians, guide them, and that's how like the technology adaptation is the thing which is missing, and we need to adapt to the not only to the hardware software part of it, but also to the hardware part of it. Integration is something very important to be looked at.
Okay. Thank you, Asad Sahab. Dr. Laik, sir, as just Asad Sahab has mentioned, we do teach theoretical concepts, train our students in labs. However, the skill part is missing, and it's not actually imparted in the quantity or on the level that it needs to be imparted, so that it can be a job employment opportunity for our youth as well. Please comment on that, and also please comment how we as academics, we write papers, we do research, we do work in our labs, but there is a big gap between our research and impactful implementation of our research. So where do you think and how we can do that, and how can these organizations that are sitting with you can help us do that? Thank you.
Okay, thank you very much. Bismillah ar-Rahman ar-Rahim. Academia is actually ready, and they have well qualified faculty and students in a sufficient number. They pick problems from the literature, they publish papers, they work on other people's problem. And actually, the thing is that we are here working on other people's problem, and you have heard from everyone, especially from the academia people, कि हम दूसरों के problems पे काम कर रहे हैं. And the reason is that actually जो local problems हैं उनको address करने के लिए we need our power industry to have R&D, and actually that R&D doesn't exist, that is missing. Then the most important thing is that if the power industry start R&D, they will have problems and they will come to academia. And then the academia will work on the local problems which they have, and the academia will provide the efficient and economical solutions. But the problem is that the industry and the academia need to be tied up. I don't know whether there is a mistrust or something else, because we know that the defense industry, they actually target in Pakistan 1 or 2 universities, and you know those universities. And they give their problems to those universities only, which are specific 1 or 2 universities. And they don't give their problems to the other universities, and maybe they have very few problems and they can be only addressed by those people. So we need to enhance the collaboration between the industry and the academia. Then we can address the local issues and work on the local problems. Over the last 2 days, we have heard so many things. And basically the things seem that we are playing ping pong. The industry people, they say we are looking towards academia, and academia looks towards the industry. And the industry actually have no problems. They have no R&D. They have no products to sell. If they have the products, they have the things. If they have the products, they will obviously they will improve the quality, and they will enhance the quality, and they will make them more efficient. But actually the power industry in Pakistan, they actually know they have no R&D. So first of all, in the power industry, they should start the R&D. In the faculty, if you see throughout Pakistan, we have the people in different areas in power sector. They have worked in different areas. Me, myself, I did work on the FEX controllers in my PhD thesis. And then after that, I'm working now in microgrids and smart grids and the MPPT problems. So actually, those are the problems which we take from the literature. And if you see, some people from the industry, they pick problems from the internet, which are open, everyone knows, and they say, work on these problems. So we are open. So actually, to address our own issues and local issues, we should have the R&D in the industry, or particularly in the power industry. As far as our curriculum is concerned, or curriculum is okay, we have the people in IAB Industrial Board, the people from the industry, and we have regular meetings, and we listen to them, and we incorporate their suggestions into our curriculum where it is required. Our labs are okay, whatever we do, the experiments in different subjects, and we have evolved, and we are evolving the curriculum as well with the time, and we are up to the new things that are coming in our in the curriculum or in the education, and we are regularly updating our curriculum. So I think there is no problem with the engineers that we produce. The engineers, they are okay, they have no problems, because we take feedback from the industry, and the feedback from the industry is very good. All the engineers that we produce are well equipped with the new things, with the new technologies and the new concepts. And time to time, we introduce new courses into our SOS in our curriculum. So the students that we produce, or the engineers that we produce, I think are up to the mark, and they are doing well. And if they confront any problem in the industry, I think they will solve. So I think
Thank you, sir. Thank you. So the floor is open to the attendees if they would like to ask any question from the panelist, clarify some points if you want. If you have some question in your mind, you're please open to ask the questions. Ji, no one? Ji, we have a question at the back.
Assalamualaikum. I'm Safullah, representing Concession headquarters. My question is to any of the experts.
We can't hear you, please. Can you talk? Yes.
I'm Safullah, representing Concession headquarters. My question has two parts. One is about our emissions and NDCs of carbon footprints, and second is what are the hurdles of renewable initiatives, either from government side or financial problems or imports. You are experts, you have everything. You have labs, you have research setups, experimental setups. But why we cannot implement the renewable setups, for example, off-grid solar setups, off-grid hydro setups in North Pakistan, and anyone can comment what are the main hurdles, and what are the link of energy sector to emissions and NDCs and carbon crediting and reporting to NDCs, especially from Mr. Asad, who can explain.
Thank you. It's a good question, particularly with regards to, first of all, NDC, and then I believe Asad will compliment me on this. The NDC requires that we maximize share for renewable power in the overall energy mix. And it is categorized as energy sector is one of the major contributors towards the GHG emissions in Pakistan, and requires switching over of the generation side and the consumer side towards the cleaner sources of electricity. Side by side, it also requires acquiring energy efficiency and replacing use of fossil fuel in transport sector as well. So from the NDC side, these are the important things which are very important for us, and accordingly, the regulatory and the policy regimes are set in place, and we are now heading towards these directions. Answering to your second question, why renewable powers are setting not getting that popularity. There are two segments. On the on-grid side, the challenge before the government is that we already have surplus electricity. The installed capacity, as I indicated in my presentation, is touching nearly 40 gigawatt, and the plants which are coming on, with those, our installed capacity is going to reach more than 45, 46 gigawatts, whereas the demand of electricity is within the range of 24 to 28 gigawatts, and projected demand to 2025 is not more than 29 gigawatts. So that means we already have surplus electricity available, and if we continue on adding more generation capacity, that will require us paying more capacity charges. That will increase the tariff and makes the electricity more expensive for the end consumers. So this is a challenge before the government, that is not only inducting new capacity, not especially renewables, but having new contracts for electricity generation is at the moment, it's not decided so far. For off-grid, there are no predeterminants, there are no bar at the system. We are not discouraging that the off-grid electricity be coming up from the renewable power generation. Myself personally has undertaken several initiatives, particularly in AJK, Gilgit-Baltistan, Malakand division, and other parts of KP for utilizing micro hydro power for electricity generation and transmission to the grids and other areas. Similarly, there were a number of villages have been electrified using solar power. I myself undertook a project for electrifying more than 60 villages in Sina, Baltistan. And then more projects have been taken by provincial governments to supply stand-on solar systems to electrify those villages. There's no bar on it. The people are doing it, and the new regulatory regime that is calling up on the microgrids for supplying electricity is going to open up a new venue for the private sector investment, and the things are going to move on. Thank you. Asid, if you can elaborate more.
Assalamu alaikum. My question is regarding the net metering. Is the current policy of net metering is fair for the consumers? And why it is not consistent?
As far as I know, since 2015, the regulation is same, rather is made more conducive at part of the consumer. We have tried to remove all the hurdles that stop the net metering and discourage the consumers. Rather, there's a huge cry from the government side and distribution side that the net metering is more friendly towards the consumers, because from the generation perspective, the electricity tariffs that NEPRA has given for renewable power projects is nearly around 6 rupees, whereas electricity from net metering based connections, which the grid is importing, is around 13 rupees. That means at the double rate. And then the distribution companies and the Central Power Purchasing Agency has been crying that this is a huge sum of burden upon them. And in one way, it is lessening their sales, leading to us less operation of their generation capacity. And thirdly, it's transacting in electricity at not a compatible rate. So in our perspective, the current net metering regulations are more consumer friendly. And that's why the consumers are aggressively switching. From the last couple of years, the megawatt that have been installed under net metering, it's jumped from 5 megawatt to 33 megawatts right now. And the number of consumers that were switched to net metering are now 18,000 plus. And this number is continuously growing. Thank you.
Assalamu alaikum. My name is Dr. Huma Blosh. My question is to Dr. Lai Khan sir. Sir, which specific potential areas do you see from sustainable technologies and modern energy where you feel that industry participation with academia would be more effective? And the second thing is that I have noticed in Kazakhstan or in Azerbaijan and Turkey, they usually provide students an opportunity in the form of internship where they have exposure to the industrial practices for the graduate and undergraduate. Is there any such opportunity provided to the university, to the students from CUI that they can have a small time to be spent in the industry to have an exposure to industrial practices?
As far as I know, I think we don't support students to work in industry, and as far as I know, in my knowledge, I think, yeah.
Dr. Sharjeel from CUI. I'd like to just add to that comment. Actually, there is a constraint on the capacity of industry to absorb students for internships. For us, I mean, we can certify that Mr. XYZ or Miss XYZ is a bona fide student of this university, and we would encourage them to go into industry and to internships, maybe starting from the second year onward, in the third and fourth year. But the problem is there are not enough slots in the industry to absorb all these students as interns. Speaking from the perspective of our regulator, Pakistan Engineering Council, they want to make it mandatory, for the students to do internships before they graduate. But the question is, if you make it mandatory for the students, is the industry going to accept this many number of students as interns? That's the question. So there's the capacity problem at the end of the industry, and perhaps there is a need to have some regulation in place that sort of motivates the industry to accept these students as interns. Yeah, thank you.
Just to respond to everyone comments, in all of our PC1s, today I just got an approval of one as well. So in all the on-site activities which the consulting firms will do, so there is by default, they have to add the stipend fee of the area, the students, engineering and non-engineering students, which are within the vicinity of that industry or area or cluster where we are working. So it would be the obligation of those consulting firms. But there is another question to it, how many students, everybody wants to do cherry picking. So I personally faced this thing from many students because we are also into our day-to-day activities, but in between, we also want to give time to the new upcoming students, but the seriousness is lacking in the student side as well. That's a behavioral aspect, which I think from most of the institutes have to be looked at, because everybody wants to do office sort of internship, office job, desk work, desk research. But once we take them, or once we ask them to go into the field within their area vicinity, even don't come to the office, just go and do this survey at least. So I have found, in my last year in the summer season, when the students came, so out of 6 or 7 students, only one was able to submit me the report. And for that, even I need to request the academia or the faculty or OREC or internship placement department of that institute to please ask him at least because I have spent my 2 or 3 hours with them discussing with. So at least that the person who was there till last day, so he should at least submit the report, something tangible coming out of it. Because sometimes that thing is missing, hard work, and that because they were being given the stipend as well. If that not would have been the case, so one might not feel sort of angry or something like that. So I definitely wrote to that university that please do scrutiny first of all before sending the students. So this is my sort of experience I had last year. Don't know this year who will come.
We have
students.
We have a process. Disappointed, yes.
Let me add to that. Actually, the thing is where the internships are paid and the students are given, a proper time there, then the students have shown seriousness. But where the internships are not paid and they're not given any time there, so the students are not serious as well.
I would again like to, because students are over here, to me, if they are giving, if some department official like Irfan Saab or I'm there looking into so many things, we are giving part of the time from our time for which we are being paid as well. So if any students come, and even though he's paid on unpaid, even unpaid students also come, and I found them more who come with the passion, they are much effective than those who are being paid. So I think like that encouragement, that students should know in which area they want to work upon. If they come with their own interest, they will be there even beyond their duty hours even. So they will find more scope into the assignment which has been given to them. So that's another perspective I again have, because it's if we are not being paid, but by working with us or people like Irfan Saab, so you can say they are self-investing on their own, even before coming into the field. So that's another perspective to it, what I can like, this is what I wanted to submit.
Thank you.
Can I
Mr.
say
Sir.
something?
Ji, ji.
Okay. I think in new documents in HEC, it says we cannot give degree until students do some practical things. Maybe they have to do some sports activity, events, they have to organize some events and do internships and like that. So I think in couple of years, all academia will have to fulfill that requirement. Normally, as in GIK, what we do is we cannot give the degree to the students until the student provides us a proper certificate from the company. So I am sad that what happened to you, but that should not be happened. At least you should write to the university so they will be careful while sending the students again to you.
Well, I think it's
Yeah.
it's on both sides. Sometimes the students need to be motivated and encouraged on our side, and it's on the other side as well. So both sides have to play their role.
One thing to add, we universities, I indicated that we produce professionals, but we have not been able to produce entrepreneurs. And this is an area where the universities have to look at.
Mhm.
We need to produce entrepreneurs. A young student should be able to put up in his own startup
Yes.
with his concepts. There are so many options now in the Pakistan to start the startups. We need to produce entrepreneurs. The world over, this concept is now so flourished.
Yes,
We need to
yes.
look at that perspective.
Yes, it is. We are actually encouraging them, and it's a COI's policy from the very start to let the students be entrepreneurs rather than job seekers. Irfan Saab, you had a question. Yeah.
Thank you very much. Irfan Hay from Commission on Science and Technology for Sustainable Development in the South. COMSETS is an intergovernmental organization of 27 member countries, developing countries, in fact. So my particular question is that from the perspective of a developing country, and rather developing countries, what would be the 5 first radical steps to turn around our energy sector, especially considering Pakistan and countries like Pakistan? Especially in terms of smart grids.
Yeah, see, we first of all have to embrace the new technologies, build the human resource, and revise the regulatory and the policy regime. These are the 3 important steps that we have to take. Till the time we don't take these 3 steps, we will not be able to make any change. Embrace the change is a big challenge. And this is the challenge which we are facing since so many years, that our distribution companies and the transmission companies, they have not been able to alter their business options. They are still lagging behind. We recently have conducted their financial health, and it was surprising for us that none of the distribution companies having positive financial health. They all are negative, and they are not on a business point of view, they are not sellable. So that is an important thing which you have to create in those things. The 2 other important elements which we should think on, and that we have to broaden our spectrum. We need to think over indigenous resources. So these are the key sources for the purposes of maximizing energy utilization. And the last one, financial liquidity, we need to manage. Without a financial liquidity, it will not be beneficial for the government to continue running this business.
If I may continue my question.
I would just like all the panelists to answer your question, I think. So,
As
sir.
per my understanding, we people in the poor countries must rely on indigenous resources. We develop our indigenous technologies, maybe it is poor, it may be started from zero. These universities may start constructing the equipments, plants, definitely their quality would be poor, but ultimately, like China, we will improve it after 1 decade or 2 decades. We will be self-reliant. Whatsoever we have, either it is hydro resource, solar, wind, or coal, or any resource which we have, we must rely on it rather than importing the fuels and technologies from and depending on the other countries. That China will give us something, something will be given us, we will start begging from Saudi Arabia and America and from here or there. We must rely, first step towards our development is that we must rely on ourselves. Our youngest develop and design, even from where I have graduated in early 90s, even I was admitted in university in 1986. There was a layman, he invented a windmill just to pump water from underground water from, and he fertilized his land. It was the first initiative. Now the technology has matured, and in those days, undergraduate students developed a windmill that is still there in Mehran University, Jamshoro. So unless we do not depend on ourselves, we will not develop. So fundamental thing is that we must rely on our indigenous resources, and we must utilize and must depend on those rather than depending on other resources and other countries.
Basically, transition is not a one-day thing or maybe a one-year thing. It's a mindset we need to adopt to. The only thing is not that we start generating from the renewable energy sources. We start generating from the renewable energy sources, then we need to improve the transmission, then utilization, the efficient buildings, efficient appliances, efficient vehicles. Again, we cannot import everything. So we import everything and we are a green economy. It's not like that. We need to involve the academia, industry to develop local products. Basically, if we are talking about the green economy, let's say electric vehicle, I think the minimum price will be like 7 million or 6.5 million. Everyone cannot afford it. So we need some local products to make it feasible for everyone. It's a green economy, green initiative. It's a mindset. It's not just government or industry or just a user. It's a mindset. It will take time, but I think Pakistan is doing good. Not like we are not very fast, but we don't have to be very fast. We are not the major contributors like China, America, or other countries. We are very small contributors, but as per the contribution, we are doing good within our financial resources. Every country have different financial resources. So the government, the industry, they are doing good, but still, I hope we will be there in coming years.
Sir, I have just one question from all the participants. Sir, Irfan has raised a very beautiful point regarding entrepreneurships. So, sir, just tell me just 2-3 important steps that we as an academia, as teachers, can take so that we can push our students for this dimension. Thank you very much.
First of all, try to make them that they can think differently. Second, they can generate ideas. Let them have their thinking, wild thinking, to generate ideas, and then push them to students को होता क्या है कि मैं बोलूं कैसे, कोई गंदा से गंदा आइडिया हो ना, वो अच्छे से अच्छा आइडिया भी हो, बोलने से कतराता है, उसको बोलने दे, उसको बोलना है तुमने, जो आइडिया भी आता है, put up your idea, then help him to implement that idea. क्या होगा, नुकसान हो जाएगा, फेलियर हो जाएगा. वो कहते हैं ना कि R&D में फेलियर नहीं है, इट्स अ लर्निंग. तो ये 3 चीजें अगर आप एकेडेमिया में कर लेना, then students will make a lot of contributions.
Well, actually, the thing is that अगर आप देखें तो आइडियाज तो डेली जो है अच्छे अच्छे पेपर्स में आते हैं, उन पे लोग काम भी करते हैं, पब्लिश भी हो जाते हैं, लेकिन जो R&D है बाहर, वो इन चीजों पे नजर रखती है और वो उन पेपर से, उन पब्लिश मटेरियल से चीजें उठा के इम्प्लीमेंट करते हैं। आइडियाज तो एवरीडे दे आर कमिंग, क्योंकि जो भी मतलब है कि काम होता है उसमें जाहिर है कोई ना कोई नॉवेल्टी होती है, देयर इज अ नॉवेल्टी। ये नहीं है कि वो बगैर नॉवेल्टी के होता है। तो पाकिस्तान में द नंबर ऑफ पेपर्स, द नंबर इज इंक्रीजिंग डे बाय डे। हर साल जो है वी पब्लिश अ लॉट ऑफ पेपर्स, इम्पैक्ट फैक्टर जर्नल्स में हम पब्लिश करते हैं। दे हैव न्यू आइडियाज, न्यू वर्क्स। जो जहां पे इंडस्ट्री है और वहां पे R&D है, दे पिक दोस थिंग्स एंड दे ट्राई टू इम्प्लीमेंट इट। द थिंग इज दैट मैं तो ये कहता हूं कि द टाई बिटवीन द इंडस्ट्री एंड एकेडेमिया शुड बी स्ट्रेंथन्ड। The industry should start R&D. They pour money. They should look. They should shake hand with the academia, and then we can work on their problems.
Yes, sir. If you want to contribute.
ये like जिस तरह भी इरफान साहब ने कहा कि जो कतराना है स्टूडेंट्स की जानिब से प्रोजेक्ट का, लेकिन एक ये भी उसके अंदर जो हमारे फैकल्टी के पर्सपेक्टिव से एक पस मंजर सामने आता है कि everyone wants a sort of out of the world thing in their projects, या जो भी उनको असाइनमेंट्स दी जाती हैं या कोई रिसर्च दी जाती है। तो सबसे पहले तो वही चीज़ होती है कि हमारे इर्द गिर्द इतने प्रॉब्लम्स हैं जिसके बेसिक सॉल्यूशंस भी मार्केट में हम इंपोर्ट कर रहे हैं या इंडिजीनियसली, मतलब उनके सॉल्यूशन प्रोवाइडर्स या सर्विसेज नहीं दे पा रहे। तो मेरा ख्याल से हमें थोड़ा सा अपना जो टाइप एंड क्वालिटी ऑफ द प्रोजेक्ट्स हैं उसको भी थोड़ा सा जो है वो प्रैक्टिकल मतलब जो नीड बेस्ड या प्रैक्टिकल ओरिएंटेड करना चाहिए, क्योंकि स्टूडेंट मेरे ख्याल से ये सोचता रहता है कि मैं इसमें क्या ऐसी नई चीज़ लगाऊं, दुम छल्ला लगाऊं कि मेरा प्रोजेक्ट यूनिक हो जाए। तो वो उससे बेसिकली सोल्यूशन प्रोवाइडर से ज़्यादा वो बेसिकली इनोवेशन की सेंस में जा तो रहा होता है, लेकिन कहीं ना कहीं बेसिक्स भूल जाता है। तो बेसिक्स शुड ऑलवेज बी एड्रेस्ड फर्स्ट एंड देन यू स्टार्ट योर जर्नी टुवर्ड्स इनोवेशन एंड अदर थिंग्स। सो that should set the foundation in a right direction.
On you've been our student, would you like to comment on what you did while you was here and now in your practical life? How do you perceive that part and now your practical life part?
Basically, in terms of entrepreneurship, I've been there. So it's not about thinking about an idea or making a product. It's about making a business case out of a product. You need to sell it. You cannot just make a product and put it on the table. This is my product. It's not like this. You need to make a business case out of it. And the product you made on the first day cannot be used in the industry. It should be tested like long term in different scenarios, in different technical conditions. Then it will be a reliable product. So I think basically what we are lacking, if we talk about the students, that we don't have entrepreneurs, we don't have an ecosystem. You cannot teach entrepreneurship to anyone. It's a mindset. It's a mindset to be an entrepreneur. Plus, you need a business mindset, not just a technical mindset. Technical mindset, you'll solve a problem. Okay. Then you need a other guy or maybe other person or other partner who can then convert that technical thing into a business case. I have seen a lot of international companies making a business case out of like very small products. They are not like a genius product. These are very small products, very ordinary products, but they have made a gold out of it because they have a good business case. They know the industry, how they want to put it, how they want to do it. The thing we are missing here, we don't know how to make a business case out of a product, how to sell it into in the industry and these things.
Rightly said. We don't have.
This pie chart of the distribution of and you have like 60% plus of the coming from fossil based generation. And my understanding is that because of contractual obligations, this state of affairs will probably continue for some years to come. So in this context, could you please elaborate what are the measures that can be taken, maybe towards energy conservation? I mean, what are the steps that can be taken, concrete steps or tangible steps? The way forward, what are the key steps that can be taken, to...
See, the second last slide before the question slide, I showed the 2030 energy mix, electricity mix, which the government of Pakistan is eyeing at. And that energy mix targets that we increase the share of renewable nuclear more than 60%. Rather, it was touching 70% while we include the nuclear. How we will do it? Of course, we want to maximize installation of hydropower. There are 23 gigawatt new hydropower is coming up. That will, of course, change the old landscape. Then we are targeting installation of more than 10 gigawatt of renewables, wind and solar. So these two sources will definitely jump up and increase the share of renewable power. At the same time, there are some renewable thermal power projects where PPAs are expiring. And in the future, the government is intending not to extend their PPAs. So they will be shelved. Third thing which the government plans to do, that curtail the utilization of RNG power plants to minimize the RNG import and more rely upon hydropower. With that, in overall energy mix, the share of clean energy will increase, jump to 72% at least. So these are the things which the government is eyeing at. And from the energy perspective purposes, in this new energy and efficiency policy, I believe Asad will elaborate that we're targeting conservation of 9 million ton of oil equivalent. So this is an area Asad can elaborate more.
Yeah, further, the pie chart was basically focusing on the grid-based electricity thing. But when we talk about MTO, it encompasses the thermal side, we talk about like transport and other sectors where fuel oil is also being used, and gas and other hydrocarbons. So the new dimension, I was like, it's sort of funny, things going on in my mind while you were discussing what tangible things. The Dolans was acquired by one of the largest European group, Arcelor, which is the largest equipment, energy efficient equipment manufacturer in Europe. So immediately, strategically, they had to shift their production facilities to grasp the Central Asian countries and other countries by keeping in view their shrinking sales by virtue of basically, when you look at their shrinking population, their stagnant population, and the sales are decreasing. So this Pakistan is a sort of like a heaven, because every year you have 1 to 1 or 1.2 million domestic consumer electricity connections being given.
It's
so,
the other way around.
Yeah. So one of the things, so if you can, so that population aspect, it's like it's everybody's choice. But like what we think we can do is from the appliance side, that if that electricity, that 1 million fans or 1.4 million ACs which come to the market, or 1.9 million refrigerators every year which are sold, so you get immediate quantified figures that this is going to be their impact if they work on peak demand. So this is going to be that demand is going to be coming to the grid. Take the case when there is no direct electricity available in the morning from the solar or from the storage system. So the grid would be the only thing where everyone will rely. And we talk about summer peaking and winter peaking. So winter peaks are totally or the shallow side. So that is another aspect where we look into the rebound effect of energy efficiency, which we are pitching right now, like go for heat pumps or more efficient ACs. And then similarly, there triggers a demand for laboratories, tested appliances, which are not there, unfortunately. But because of these big groups strategically coming into Pakistan, so they are investing into these things. They are investing into laboratories, and which indirectly will open up the job space for the engineers and other professionals. But on the other side, alignment of policies are very much to be looked at, because on one side, if government is focusing on EVs, electric vehicles, their addition into the vehicle or road transport network. But on the other side, the petroleum, as per the petroleum policy, the oil marketing companies have been asked to increase their reservoirs. Strategically, it was good, but at that time, like it was sort of going in the east direction and going in the west direction, because you are asking the oil marketing companies to secure the financing to increase their oil fuel inventories, because transport is the largest consumer of that. And on the other side, you're going towards EV. So OMCs were stuck even. Like I think that's a way to go forward, but I think NEPRA would make can bring comfort into the lives of OMCs once they notify the standard rates for charging, because so far as I know that they are going in loss at the moment by selling by charging the electric vehicles on commercial basis. The tariff what they are taking, it's not at the moment which is giving them break even. So 60 rupees is the break even point as for one or two charging stations that I've interacted with one or two of them. So they said that 60 rupees per unit would be the viable option for them to sell, or what's 180 units of electricity for 80% charging. So 100 into like 60. So that would be the optimum option where they can go for break even. Otherwise, they are facing commercial difficulties in operating their charging stations. So I don't know, can you like supplement on that thing?
Yeah, we have taken a note of the whole EV tariff infrastructure, and we have sought support from abroad as well, and we have come up with a number. It's going to be announced, I believe, by mid of April. We are going to give some concession to the EV industry. This concession, what we have proposed so far, that during the first 6 months or a year, these charging stations, being the commercial consumers, they should not be charged for MDI. This is because if they are charged MDI, then they can have a very negative impact upon their financials. But once they have running business, then the MDI can be charged. Second thing, we are not fixing the tariff that this will be the final tariff which they will be charging. We'll be giving us a cap, net of taxes, and they will be allowed to compete. If somebody can make a good business out of it and able to sell at lower price, will be allowed to do so. So in that way, we want to create a competition among the EV charging business suppliers so that they can provide better services to the consumers. So we're taking note of this 60 rupees cap, but whatever number we're going to announce, it will be net of taxes and net of MDI.
Thank you, Dr. Saab. So with this, I would just like to conclude, although this has been very fruitful debate and it could go on for hours, but we are short on time. Before we end, I would like to thank all of my panelists for coming over, giving their time, taking out time from the busy schedules, and letting the academia in on what they are doing right now and letting us contribute. Before I end this session, just one suggestion from my end. I would like anybody, any organization, any government organization can take it up. Please build a database of relevant experts on energy, whether they are computer scientists, whether electrical engineers, whether they're economists, so that you have ready-made accessible expertise quickly on your hand, and you can give short pilot projects to them so that we can start from there. Otherwise, we'll keep on going on in circles and going on this debate. Thank you everyone for attending. Yes.
Just connecting one more point, I would suggest the academia members as well to get themselves registered with the SCCP database of board of directors, and similarly the Overseas Pakistani Foundation. So most of the companies refer to those as per the corporate governance rules and pick up the persons having the area of as per the area of expertise. So this is another way to go, that you have to take the first step to come into that ambit, to be on the board and derive the board as per your knowledge and information.
Thank you, Sir. Thank you, everyone.
Okay, now I would like to invite our chief guest for today, Professor Dr. Shehzadeh Malik, our Dean, Faculty of Engineering, Comsci University, Islamabad. Sir, please.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Respected guests, the panelists, the speakers, members of faculty members, students, ladies and gentlemen, thank you very much. So on behalf of Comsci University, Islamabad, I would like to pay gratitude to the Commission on Science and Technology for Sustainable Development in the South, ComSets, and the United Nations Educational, Scientific, and Cultural Organization, UNESCO, for collaborating to organize the international seminar on the sustainable technologies in modern energy, a roadmap towards green economy. The event, as it has been held at the premises of Pakistan Academy of Sciences, for which we are very grateful. So, I believe the event has been productive and has been able to achieve its objectives by serving as an interdisciplinary forum for the academicians, the scientists, and government officials to deliberate upon important topics related to sustainable and renewable energy resources. The seminar included 13 talks by experts belonging to Pakistan, South Korea, and Spain. The subsequent panel discussion session titled Transition Towards Clean and Green Energy, which just finished now, as the participants already kind of has listened to all the discussion which has been going on, and it's really been very, very fruitful discussion. And the experts have discussed the key issues related to clean energy, as well as they have provided their advice and recommendations for facilitating transition towards the sustainable and green economy. I believe that the discussion, especially in this session, has highlighted a number of avenues and kind of in relation to the title, the roadmap, some of the action points have also been highlighted in terms of what needs to be done and what role can be played by different segments of the society. Okay? So we are really pleased. We are very pleased to have a very large number of scientists, academicians, researchers, and students from Pakistan and other member countries of ComSets and UNESCO who participated in the event, both in person and online. The registration made for this seminar was over 200. So it's been quite a good participation. And we hope that the participants found the event productive. So I would like to urge the speakers and the participants of the seminar to keep in contact and continue mutually beneficial discussion and cooperation in this important area. So in the end, I thank my colleagues from ComSets University, Islamabad, Professor Dr. Laik Khan, and Dr. Shajil Wine, Head Department of Electrical and Computer Engineering, and their team members, as well as organizers from ComSets headquarters, Mr. Irfan Hai, Dr. Huma Baloch, and Mr. Mansoor Farid, and all others, UNESCO for funding this, for making excellent arrangements for this international seminar. With this, I thank you all again, and Pakistan, Zindabad. Thank you very much.
Thank you so much, sir. Now it is time for the field distribution ceremony. I would like to invite Professor Dr. Shehzadeh Malik, Professor Dr. Laik Khan, Irfan Hai Saab, and Dr. Shajil Wine. Sir, please. Firstly, I would like to invite Dr. Syed Ali Abbas Kazmi Saab, Assistant Professor at NUST, Islamabad. Next, Dr. Kamal Shahid, Assistant Professor, Punjab University, Lahore. Next is Engineer Asad Mahmood Saab, Manager Technical, Nika, Islamabad. Next is Dr. Masroor Hussain, Associate Professor, GK Topi. Next is Dr. Irfan Yusuf, Advisor Technical Renewable, National Electric Power Regulatory Authority, NEPRA, Islamabad. Dr. Sobia Beg Sahiba, Head Energy Research Center, Comsai University, Lahore campus. Mr. On Muhammad Arshad, Country Manager, Elam Energy, Pakistan. Mr. Mr. Ali Nawaz Sahab, Director General Projects, Ministry of Energy, Power Division. Professor Dr. Laik Khan Saab, Chairman EC and Member Organizing Committee. Dr. Shiljil Wine, HOD, Electrical and Computer Engineering Department and Member Organizing Committee. Mr. Irfan Hai Saab, Director Programs, Comsys Secretariat. Mr. Azizul Haq Saab, Lecturer, Department of Computer Engineering, Comsat Islamabad. Mr. Imran Lodi Saab, Research Associate, Department of Electrical and Computer Engineering, Comsat Islamabad. Myself, Ahsan Malik. I would like to request Dr. Shijil, please. Now I would like to request our Dr. Laik Khan Saab to present souvenir to our chief guest, Professor Dr. Shehzad A. Malik. So thank you so much, all the respected speakers and panelists, for sparing your valuable time and traveling from different parts of the country. Furthermore, I would like to thank all the participants for sparing their valuable time for this exclusive seminar. I hope this seminar will pave way for sustainable and green energy in Pakistan, inshallah. Please join us at tea. Thank you. So, okay, we need to have one group photo. So I would like to request everybody, please. Okay. I would like to request all the participants to please gather outside the building so that we can have the group photograph.